Summary. Let us summarize what we have learned. A linear programming problem is one that is concerned with finding the optimal value, maximum or minimum of a linear function of several variables called objective function, subject to the conditions that the variables are non-negative and satisfy a set of linear inequalities called linear constraints. Variables are sometimes called decision variables and are non-negative. A few important linear programming problems are 1. Diet problems, 2. Manufacturing problems, 3. Transportation problems. The common region determined by all the constraints, including the non-negative constraints, x is greater than or equal to 0, y is greater than or equal to 0 of a linear programming problem is called the feasible region or solution region for the problem. Points within and on the boundary of the feasible region represent feasible solutions of the constraints. Any point outside the feasible region is an infeasible solution. Any point in the feasible region that gives the optimal value, maximum or minimum of the objective function is called an optimal solution. If the feasible region is unbounded, then a maximum or a minimum may not exist. However, if it exists, it must occur at a corner point of R. Corner point method for solving a linear programming problem. The method comprises of the following steps. 1. Find the feasible region of the linear programming problem and determine its corner points, vertices. 2. Evaluate the objective function z is equal to ax plus by at each corner point. Let m and m respectively be the largest and smallest values at these points. 3. If the feasible region is bounded, m and m respectively are the maximum and minimum values of the objective function. If the feasible region is unbounded, then 1. M is the maximum value of the objective function if the open half plane determined by ax plus by greater than m has no point in common with the feasible region. Otherwise, the objective function has no maximum value. 2. M is the minimum value of the objective function if the open half plane determined by ax plus by is smaller than m has no point in common with the feasible region. Otherwise, the objective function has no minimum value. If two corner points of the feasible region are both optimal solutions of the same type, that is, both produce the same maximum or minimum, then any point on the line segment joining these 2 points is also an optimal solution of the same type.